So, again, going back to Mr. Lewis, you can apply his awesome little um, dot notation not only to individual elements, but also to compounds. So these are reactions that show how we can make these compounds out of Lewis dots. So, for example, sodium will give its one valence electron to fluorine, and we get this. Fluorine's got 8 valence electrons. It's all happy. Sodium, it doesn't have any. Well, you probably think, how can it not have any? But you gotta remember, right under that coating of that one valence electron, there's 8 more that would love to be revealed. Let me just find it. I think I had that. Oh yeah, right here. So this is sodium. Remember, if it gets rid of that one valence electron, it's opening up a whole new octet under it. So basically, both sodium and fluorine complete their octet. And sodium gets a positive charge because that it loses that electron, and fluorine gets a minus charge because that it gains that electron. So now let's do some covalent stuff. Here we got hydrogen, and that's got 1 electron. Another hydrogen which has got 1. So we can give 1 of hydrogen electrons there and 1 here, and we can actually share these electrons. And now we got these. And actually, for hydrogen, helium, lithium, and beryllium, 2 is enough to complete their octet. There's a little bit of an exception there. And then oxygen has the 8 that it wants. So this, if you didn't catch it, is actually H2O, water. And then here's one of those coordinate covalent bonds. We got oxygen plus oxygen and they bond, but something's not right here. So let's count these valence electrons. 1, 2, 3, 4, 5, 6 on each oxygen, so that's 12 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 14 electrons on this side. Well, it doesn't show anywhere that electrons were added because they weren't. This is actually a mistake, and I'll show you how we can correct that. If we get rid of some valence electrons, we can actually double bond this compound. So we used to have only 1 pair of electrons shared. Now we have 2 shared pairs of electrons. So this is what we call a double bond, because there are 2 pairs of electrons. And if we recount 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that is the correct notation for oxygen. So that is pretty cool how I just did that. So let's write some Lewis structures.